Hello students, this is Mr. Nguyen. Today I am going to show you how to use your Desmos graphing calculator to solve quadratic equations, okay? Before we begin though, let's talk a little bit about all the features of a quadratic equation, okay? So to type the x squared, you need to hit Shift 6 to get to the exponent and then put a 2 there. And notice your cursor is still in the exponent, so you have to hit the right arrow key to get out of the exponent, okay? So this is the parent function of a quadratic equation, all right? It's pretty typical. It opens up. It has a little vertex right here at 0, 0. And the x-intercept is also at 0, 0. The y-intercept is also at 0, 0. Now, to get additional, to see the additional features that well, it's still there, but to see this graph a little bit better, I'm going to do a different equation. So I'm going to move this graph down 4 units. So as you can see, the vertex from 0, 0 moved down 4 units because I did the -4 right there. Okay, the reason I'm using this example is so that I can show you what you're looking for when you are solving this by graphing. Okay, so when you are solving this by graphing, so this is a nice thing about Desmos. If you have never used it before, you can zoom in and zoom out of the graph very easily, and you can move your graph around very easily by just pressing on your mouse and just move it around. Also, the graph will indicate where your critical points are, right? So if you hover your mouse over these locations, you can actually click on it. It will give you the location of those points, right? So let's talk about these 3 points, okay? Oops, it deleted. So this one is called the vertex, okay? This is the vertex. It is the tip of your graph, okay? And for this problem, it is where 0, -4 is, right? So the 0 is the x value, the -4 is the y value. So the -4 is also known as the minimum of this graph, right? It's the lowest point of the graph, okay? The other 2 points are the most important ones for this particular lesson is the x-intercepts. So one at -2 and the other one is at 2. Well, you need to know that the intercepts right here have many different names. The x-intercept, I should say, the x-intercepts. The x-intercept have many different names. The x-intercepts are also known as the solutions of your equations, okay? And it is also known as the um, uh, zeros of your zeros of your function, and I should say they, because you have 2 of them here. They're also known as the roots of the function. Okay, so these 4 different words actually mean the same thing. Okay, so when you are graphing any quadratic equation, you need to be able to identify these points right here. Okay, that's one right there, and there's one right there. And once you do that, you could actually solve pretty much any quadratic equation. Okay, so let's try one more. By the way, sometimes they write the equation as they're using n or p or w for their variable. When you're typing into Desmos, you need to use the x variable. Okay, so let's try a different one. Let's try a trinomial. So x squared minus 8x minus 9. So if I were to factor, I could solve this, right? But without factoring, I can also solve it, right? So let's clear this. And so, so you can see here, you don't see the whole graph. So I need to zoom out a little bit and then move my graph. Okay. As long as you can see it. I mean, if you can zoom out all the way to see all the vertex and everything. But if the question doesn't ask you for the vertex, then you don't need to see the vertex, right? You really just need to see the x-intercept, which is right here. There's one right there. And there's one right here. So one of the solution is negative, which is -1. The other solution is +9. So those are where your solutions are. These are the answers to your quadratic equation. Okay, let's do one more. Let's do a hard one. Maybe your leading coefficient is something different, like say 6x squared plus 10x, maybe plus 10x. It's more complicated, right? Minus 12, for example. Okay, so as you can see here, you can still see the answer. It's not a very nice number, but you can still see where it is. It's going to be rounded, right? It's going to be approximation. It's rounded to the nearest thousand, but you can still see it. Here's one right here. The x-intercept here is negative 2.470, and then this one here is 0.808. So as you can see, this graph has two solution, right? Two solution because there are two x-intercepts. Okay, now there are some graph where you only have one solution, and that's when your graph actually only touch the x-intercept at one point. So let me try one to see if I can manipulate this equation where it only touches one place for you. Okay, also if I can do this, if I can do that. Oh, now it's way up here. It doesn't have any. Oh, let's talk about this one. You see this graph right here? It's moved all the way off of the x-axis. So in this case, we have no x-intercept. So when you have no x-intercept, that means no solution. So that's another case. Okay, but sometimes you do have a solution. Oops. Sometimes you do have a solution. So let's try x squared plus 2x, oops, plus 2x plus 1, maybe. Okay, this one will work. So as you can see here, the only place where the graph touches the x-axis is at -1. So in this case, this equation only has one solution. Okay, so guys, I think this is pretty self-explanatory. You can just type in your equation in here, get a graph, and find out where your x-intercepts are. Um, and that's pretty much, those are the solutions to your equation. And remember, if you only have one x-intercept, of course, you only have one solution. If you have no x-intercept, then there's no solutions. Okay, I hope that helps. And if you have any questions, you can send that to me. Don't forget to subscribe to my channel. Thanks for watching. Bye bye.